Okay. Okay, so they specified that we are doing, in part A Riemann sum with 3 subintervals, a midpoint Riemann sum with 3 subintervals. There's only one way we can do a midpoint Riemann sum with 3 subintervals. One from 0 to 8, so that we have a midpoint at 4. One from 8 to 16, so that we have a midpoint at 12. And one from 16 to 24, so we have a midpoint at 20. So this time, the width of each interval is going to be 8. So you guys recognize that I'm approximating the integral from 0 to 24 of r of t dt, right? Which is the amount of change in the volume of the water from 0 to 24 hours. So a midpoint Riemann sum, for my first interval, the width is 8, the height is the midpoint, 8.8. My next subinterval, width is 8, height is the midpoint at 9.2. In the last subinterval, my width is 8, and the height is the midpoint, which is at 8.1. You can type that all into your calculator. Of course, if you were doing this by hand, to make that process easier, I would factor out the 8. Oh, not that you had to do that. Since you had the calculator, it wasn't such a big deal. But if you didn't have the calculator and you did have to do this by hand to make that calculation easier, that's what I'd definitely do. What did you guys get? 208.8? What unit of measurement would that be? Gallons. So that's the amount of change. Really, we're saying this is equal to, I don't know, maybe we'll call it V for volume at time 24 minus the volume at time 0. We know that the volume at time 0 is 150 gallons. So if I add that 150 gallons to both sides, 150, so at time 24, the volume would be 358.8. Is that what you guys got? Gallons? If we started at 150 and we added this many gallons, then at the end of that 24-hour period, that's the volume of our tank. Okay. Any questions about that one? When do you guys want to plug it in for me? I'll come around there. Untangle it. There you go. Thank you. Okay. In part B, we're supposed to estimate the number of gallons of water in the end of 24 hours by taking a trapezoidal sum with 3 subintervals and values from the table. Show computations that lead to your answer. I do want to point something out here. There's nothing that says that we have to use these same subintervals. So I'm going to use the same subintervals, the 3 equal width subintervals, but you don't have to. I could have gone 0 to 4, 8 to 16, 20 to 24 and done a trapezoidal sum if I wanted to. Since they didn't say 3 equal subintervals, there's several ways that we could have done this, but I'm going to stick with the subintervals that we have already. And again, I'm approximating the integral from 0 to 24, r of t dt. Using a trapezoidal sum, if I use my first partition 0 to 8, then its area is 1/2 base 1 would be 8, base 2 would be 9.3, so 8 plus 9.3 times the height would be 8. One of the advantages to using equal subintervals is kind of like up here, especially if you're doing it by hand. If I'm using equal subintervals, I'm multiplying each term by the same factor. I could pull that factor out. My next subinterval from 8 to 16 would have an area of 1/2. Base 1 is 9.3 plus base 2, 8.9, times the width of the partition is the height, 8, plus the third subinterval has an area of 1/2. Base 1 would be 8.9, base 2 would be 6.7, and the height is the width of the partition, 8. If you wanted to, you could factor the 1/2 times 8 out, so you could pull the 4 out and just add everything, especially if you had to do it by hand to make the calculations a little easier. What'd you guys get for that value? What about just the area? 204.4 gallons. We could think of this as fundamental theorem, or we could just think of it as if I started at 150 gallons and I added another 204.4 gallons, then the volume at the end of that 24-hour interval would be 254.4? 354.4. Thank you. Any questions about the trapezoidal or the midpoint approximations there? Now, on the last one, they've given us a model for R of t. It's 1/75 of 600 plus 20t minus t squared. So now I can find the actual amount of change by integrating that function from 0 to 24. I'm going to pull the 1/75 out. Not that it matters because we're going to do it with the calculator, but we could do this by hand. So we're going to do it on the calculator just to review how we would evaluate that on the calculator. So I have 1/75 times. Then to get the definite integral, I'm going to go to F3 and choose integrate. I'm going to type in the function that I want to integrate, 600 plus 20t minus t squared, comma, the variable I'm integrating with respect to, t, comma, my lower bound, 0, comma, upper bound, 24. Let's get a decimal. To get a decimal, so you have two options for a decimal. You could either type in a decimal somewhere in what you typed in. So if I had typed in like 600 point, if I type in a decimal, it assumes I want a decimal. Or if you press the function button and then enter, you guys see that little approximation symbol there? If you press that before you press enter, it'll give you the decimal. By the way, we could have done that with the 84 too. So those of you that don't have the 89, we would have gone to math, selected option 9, and then filled in the blanks. 0 to 24, 1/75 times 600 plus 20. I'm going to go with x just because it's faster to type in. Minus x squared with respect to x. Exact same thing. And again, this is the volume at time 24 minus the volume at time 0. And we're saying that that is 207.36 gallons. So we found the amount of change. $207.36. So if I add the 150 to that amount of change, keep doing that. 357. Thank you. The numbers that are going on in my brain are not transferring to the paper this morning. Do you guys have any questions about that one? Pretty easy. Okay.